Okay, we want to look at another differential equation. Or x prime, I guess I'm doing. X prime equals 3t times 1 minus x squared. X of 0 equals 2. And I did this one in Sage, and again, you know, you have to, this part you're going to have to do by hand, it looks like, no matter what. And I have my dx over 1 minus x squared, and then my 3t dt, and those both get integral signs. And so we need to do this. Now the right hand side, no big deal, but the left hand side, I don't know how to do that without doing partial fractions. Now, actually Sage did that antiderivative just fine. But for me, let's see, I'd probably write it as negative 1 over x squared minus 1, because I like the x squared first, equals, you know, and then we need an a over x minus 1 and a plus b over x plus 1. And I'm not going to go into the partial fractions, but what we'd find is that a is negative 1/2 and b is positive 1/2. And so what we have is, this is the antiderivative of 1 over 2 times x plus 1 minus 1 over 2 times x minus 1 dx equals antiderivative 3t dt. And so here we'll have a 1/2 log, and I'm going to write it as log instead of ln, just because that's what Sage does as well. So minus 1/2 log x minus 1. Now, I didn't put in the absolute values because actually the antiderivative is absolute value. However, I noticed that x of 0 is 2, so x is going to be at 2, and both of these things are positive. You know, x minus 1, that'd be 2 minus 1 is 1. Well, so actually 0, but these things are non-negative, these logarithms, so I didn't put the absolute values in. And then equals 3t squared over 2 plus c. And so now, I think the easiest thing to do would be to multiply everything by 2. And so I have log x plus 1 minus log x minus 1 equals 3t squared plus 2c. Now you could rename that as some other c. I'll just leave it as 2c. Now, if I want to solve for x, and actually I have my options here, I could solve for c right now. Actually, might not be a bad idea, but I'm not going to. But you could. I could put in 0 for t and 2 for x and find c. Well, let's go ahead and do that, I guess. So this would be log 2 minus log of 1. Oh wait, x is 2, so that's log 3. Sorry. Log 3 minus log 1 is equal to 2c, but log 1 is just 0. And so what we see is 2c, which is actually what I need, is log 3. So now what I have, well, if I can move that down a little bit, I have that log x plus 1 minus log x minus 1 is equal to 3t squared plus log of 3. And in order to solve for x, I have to use properties of logarithms. And now this is something else I found out. Sage isn't going to do this for you. This is the log of x plus 1 over x minus 1. And so this is 3t squared plus log 3. So yeah, Sage just, it's not going to do that for you. It'll do everything else, but it's not going to do that particular combination of logarithms. Don't know why. I would think that, you know, with all the rules it has stored up in there, I would think it would know that one, but it doesn't do it. I have not found a way. I did a lot of searching with Google, and pretty much they say it's not going to be done. But now that I have this, I can exponentiate both sides. And so I have x plus 1 over x minus 1 is equal to e to the 3t squared plus log 3, but that's e to the log 3. So that's just a 3. So I'll just put a 3 in front of there. Right, because e to the natural log of 3, which is just 3, times the e to the 3t squared. Okay, so I have this, and now I have to solve for x. So I have x plus 1 equals 3e to the 3t squared times x minus 3e to the 3t squared. Bring this x over and take that 1 over, and so I have x minus 3e to the 3t squared times x equals minus 1 minus 3e to the 3t squared. And so solving for x, I get x equals, well, there's a negative here, so I think I'm going to write this as 3e to 3t squared plus 1. So I took that negative out of there, and so on the bottom I'll have 3e to the 3t squared minus 1. And so there is my solution. Okay, and again, if you did this with technology, it's really not too bad, except there are some pieces you have to do. So you have to separate the variables to begin with, so you have to do that. Now it will do the antiderivatives just dandy for you, and so you would get to here. You would have that thing. Now, you know, if you wanted to do like I did, multiply both sides by 2, which actually I do in the Sage video, and the reason I do is because Sage does not combine these logarithms, and so, you know, I made Sage do that. I multiplied both sides by 2. I did not solve for C right away. I could have, but I didn't. And so you get to this thing where instead of a log 3, you've got a 2c. And so then, you know, I had to tell Sage that this left-hand side was the same thing as that. It didn't seem to know that. Now, if I gave it the log of x plus 1 over x minus 1, and I told it to expand or something, it would probably expand it into the two logarithms, but it did not combine them. But once I made that equation, then Sage was able to get to here in one step. I just said solve for x here, and it gave me this. Now I say this, I think I still had a 2c in there, you know, a plus 2c, because I hadn't solved for c yet. But then I solved for c very simply in Sage and got the basically the same answer. I don't remember, in Sage it might have left it as e to the 3t squared plus what was 2c log 3, so I think log 3 like that, and plus 1, and then the same thing on the bottom with minus 1. But it did not realize that that's just 3e to the 3t squared. You know, again, technology is great, but it's not everything, and that's where, you know, if you find some of these algebraic steps are a little rough, you as a math major should be doing that on your own. Work on your algebra. Okay, I'm not teaching an algebra class. I am teaching a differential equations class. You know, you have to work on your algebra if you are weak on it. And, you know, from what I've seen, many students nowadays are much weaker on it than they used to be, although it's never been great. So, you know, if you hear some older people, you know, saying, oh, they just don't know it like they used to, well, that's sort of true, but I've had students with pretty poor algebra skills, I mean, pretty poor algebra skills for years and years and years, and so I would say I don't tend to see as many students with great algebra skills as I used to, but again, even they were kind of few and far between. And so let me just finish writing this thing: 3t squared minus log 3, and then plus log 3, and then minus 1. You know, so definitely, if any of this algebra is a little rough, well, go back and review it on your own. Again, you're in math, I assume, because you like it, and so work on these things if you find you're a little weak on them. Again, I think I mentioned earlier, I forget all kinds of stuff. I go back all the time to refresh myself on various things. You know, so it's not like you learn it once and you know it forever. It's easy to forget things, and so there's no issue with going back and relearning things. Okay, I mean, it's just what you do as a mathematician. All right, so not too much there, but plenty to keep you busy. All righty.